Alright, here we have the cumulative review from chapter 4, and let's look at number 3 and number 4. Number 3 wants you to find the derivative of f, but f is comprised of the function x squared times g of x. So this is simply a product rule where that's our f and that's our g. And so the product rule tells us f prime g plus f g prime. So if f is equal to x squared, then that means the derivative is 2x. And g prime, if g is g of x, then that's just the derivative of g of x. And since we don't know what's inside the function, we're just going to leave it as g prime of x. So putting it all together, we have 2x times g of x. That's that part right there, plus f, which is x squared times g prime of x. And look at our answer choices. X squared is partnered up with g prime. And I don't see, well, I see that part right here, but I don't see 2x partnered up with g of x in that one. So maybe we need to try to factor it out and match it up with one of these other equations. So we notice that we have an x and we have an x squared here, so that means we can factor out the quantity x, and we get 2g of x plus x g prime of x. And looking at the answer choices, let's see, we have x g prime of x, x g prime of x here, and 2g of x with 2g of x, and our x is factored out in the rear, which is not orthodox and not common, but we can live with that. And so we'll just pick A on that one. Alright, let's look at number 4. It's got a local linear approximation of a function will always be less than or equal to the function's value. So we're looking for when is it always less than, and it's asking us based on the point of tangency. Well, that's just a fancy way of saying the tangent approximation, right? So the answer choices have concave up, concave down. The tangent line is exactly horizontal, and the tangent line is exactly vertical. Well, we know we can't take the derivative of a tangent line that's vertical. It's undefined there. So let's take a look at what is concave up and concave down. So we have two different functions, and this one is concave up and this one is concave down. And let's see if I can draw some tangent lines for us. Let's focus on the concave up. So if I have a concave up function and I draw a tangent line, let me draw one over here in this situation where the function's decreasing in this little segment here. What do you notice about those green tangent lines? They are always below the curve. If it's below the curve, then the estimation is less, because the tangent line is the approximation. Well, let's just double check and draw some tangent lines on our concave down function. So that would be a tangent line there. And let's draw one over on this side. And you can look at this one and see that the green tangent line is always above the curve. If it's always above the curve, that means it's greater than. And greater than tells me that this is a over approximation, and this is an under approximation. So we're looking for when it's less than, so we're looking for an under approximation, and it looks like that happens when it's concave up. Okay, hopefully that helped, and we'll try another one.